right, so next, let's look at an example of finding a linear equation given the graph of a line. Now, we've done this before, but previously when I gave you the graph of a line, oops, sorry, this window just popped up. I was thinking that I wanted to, there we go. Okay, where was I? Okay, so previously I gave you the graph of a line, but I identified points on the line for you. Now I haven't done that. So here you just have a graph. So we need to find the equation of a line shown in this graph. So how do we go about doing that? So there's a couple things you could do. Number one, probably the easiest is to maybe look for x-intercepts and y-intercepts. Okay. And the x-intercept is going to be right about here, right? But that is problematic because as we look at this graph, notice that if I kind of draw a little bit of this grid, all right? So I'm kind of redrawing this grid between 5 and 6, and you can see that our line isn't going through 5 and 6 exactly. It's somewhere like that, right? Can you see that? Right. So if you look at the line right about here, it's not going exactly through the intersection of our grid. So we can't say exactly whether this is 5 or 6. So what we need is something like what we see with the y-intercept. Okay, right here with the y-intercept, if I kind of redraw the grid around that, kind of doing like a zoom here. And so this is -4, -4, -3, -5. And you can see our line is going right through the intersection where the y-axis intersects this -4 tick mark. So our line is going right through that point. So that's very clear. So that's a point we're going to use. So we can use the y-intercept, which is going to be 0, -4, but we can't use the x-intercept because it's not clear. It's not clear exactly what that is. All right. And so in order to find the equation of a line, we want to put it in slope-intercept form. And so we need to get the slope. And we need the y-intercept. Now, what's good is we just found the y-intercept. Okay, we got lucky there. But in order to find the slope, we need another point. Okay, so in order to get the slope, we need another point. So I would say right now with the y-intercept, we have our y2 and x2. We have our, we'll call this x2, y2. We have those. Okay, so we have to find another point on this graph where the graph is going through a clear intersection on our grid. And that's why I gave you this graph on like grid on graph paper, okay, on a gridded XY plane. So as I'm looking at this, I'm trying to find another point where it appears to be very clearly going through an intersection. And I think I see one. So the one that I'm looking at here is at 7, 1. Right there. Okay. So I think the point 7, 1 would be one you could use. It looks like maybe 3, -2. is another one that could be used. Um, let's see here. So that's our y-intercept. See here, up 2 over 3, up 2. So it looks like this graph may be off a little bit. Okay, that's okay. We're just going to do the best we can. So I'm afraid that we are going to get a different slope and y-intercept if we choose this point as our other point, or if we choose that one. I'm pretty sure we will. We got the space. Let's go ahead and test that out. Let's test that theory out. That'll just give us some more practice. Okay. So number 2, our second point. Let's make our second point. Let's do maybe scenario alpha will be our second point is going to be 3, -2. So we will have x1, y1 will be the point 3, -2. And then we'll have scenario beta. And I'm doing some extra work because I just want to see if this is right. The reason why I suspect this is going to be different is just notice that when we go from our y-intercept to the next point, we have a rise of 2 and a run of 3, +2 and +3. But now when we go from the second point to the third one, we have a rise of 3 and a run of 2 and a run of 4. So you see how the slope between these 2 points is going to be different than the slope between those 2 points. All right, so that's why I'm thinking it's going to be different for this second scenario. So let me use a different. And another reason why I'm doing this is maybe to show you how it's hard to read from graphs. You know, it's hard to read from graphs. And so the second one is going to be the 0.71. All right. So if we were going to calculate slope with this x1, y1, and this x2, y2, you can have y2 minus y1 over x2 minus x1. I highly stress that you always rewrite your formulas every single time. So y2 is -4. That's going to be minus y1, which is -2, all over x2, which is 0, minus x1, which is 3. And let's see, that's going to give us -4 plus 2. So -4 plus 2 is -2. And 0 minus 3 is -3, which is actually going to be just a positive 2/3. So that is what our slope is equal to. So if we were going to come up with the equation of a line using scenario alpha, we would have the slope-intercept form would be y equals 2/3 x, and our y-intercept, our b, is -4. So that's what we would get for an answer for this one. If we had chosen 7,1 as our point, let's see what we get with that. So slope is equal to y2 minus y1 over x2 minus x1. Y2 is -4 minus. Now the y1 I want to use, the y1 and x1 I want to use are these ones. And so y1 is just 1. X2 is 0 minus x1, which is 7. So that's going to give me -4 minus 1 is -5, all over 0 minus 7 is -7. So that gives me a slope of 7/5. So, you know, you can see it did create a difference here. All right, so then our slope intercept, it's going to be y equals 5/7 plus, or I'm sorry, -4. All right. So I did the best I could actually when I created this example and I put this line on this graph to make sure that it went, you know, undeniably through, the intersection in a grid. Um, but it looks like I didn't line it up exactly right. And so you can see why it's so difficult to actually get the equation of a line from a graph because depending on how well the graph was made and how it was blown up, it may be difficult to actually find exact points. Okay. And it's so critical that you can get two completely different answers. Um, you know, if you just choose your points not very wisely. So, um, but that's how to do it. So you kind of saw two examples in one. And I also showed you some pitfalls that can happen when you're doing this. So let's go ahead and move on to this think, pair, share. Go ahead and pause the video right now. And when you come back, we'll work this one through as well. Okay, go ahead. All right, we're back. So use the previous example as a model and um, notice that we have a y-intercept right here at 0, 1. So we've got 0, 1 is our y-intercept, which means B is going to be +1 in our slope-intercept form. And maybe the next point that it crosses is maybe the 0.54. So right here, so at the 0.54. Now, what we can do is last time, we used the slope intercept. I'm sorry, the formula for slope to calculate slope in that last one. But this one, it's pretty clear. Remember, slope is rise over run. So as we go from our y-intercept to our next point, we're going to go up 3. So we have a rise of +3, and then we're going to have a run of 5. So we have a rise of +3 and a run of +5. So that gives us a slope of 3/5. Now you could, of course, use the 0.01 and use the 0.54, and you could put both of those in to your slope formula, and you'll get 3/5 also. Okay. What I'm showing you is a shortcut and kind of the power of the slope intercept form and how cool it is to be able to use it. Okay. So with the slope found and the y-intercept found, we can put the equation to this line and slope intercept form, just like that. Let me know if you have any questions.